The third requirement of a logistic regression model is that we have a large sample size. Maximum likelihood estimation is the way that we find the intercept and coefficients for a logistic regression model, and it is an iterative optimization procedure. So what's an iterative optimization procedure? Well, imagine that you're hiking in Alaska and you're trying to find the tallest location in the United States, Denali. So Denali rises over 20,000 feet into the air, and you want to be standing right in that location. So you have your GPS watch and you have the latitude and longitude of the highest location, and you're just not sure exactly where it is. So you're standing in a particular location and you look at that watch and you say, okay, I am not in the tallest location. So you take a step to the right and then you say, no, this isn't it either. And then you take 2 steps to the left and you say, no, this isn't it either. And you move diagonally forward and to the right, and that's not it either. And you just continue to move around in that location until your GPS watch latitude and longitude match what you know is the highest location in the United States, because you want to be finding the tallest point. That's essentially what maximum likelihood estimation is doing. It's setting the values of the intercept and coefficients such that it's trying to identify the most likely combination. So it's moving over a surface, trying to find the highest point. And that surface is many dimensions. It's as many dimensions as the intercept plus each slope. So it's more dimensions than we can think in. When you're standing on the mountain range, that's a 3-dimensional space. You're moving up and down and left and right. This is more dimensions than that, but you can always think back to standing on top of that mountain range, moving around, changing your location on the surface until you found the highest point. In order to find that highest point, you need data around the surface. So if you moved to the right and the GPS watch wouldn't tell you where you were, you wouldn't have enough data to decide if you were in the highest point or not. And if you moved to the left and that data was missing and your GPS watch said, geez, I don't know, then you wouldn't have enough information. So large sample gives us the ability to know when we're at the highest point. When do we have the best intercept and coefficients possible? So maximum likelihood estimation requires lots of data to create a stable solution that we're confident in. Having a large sample size also allows us to assume that our intercept and coefficients have a normal distribution when we do our hypothesis tests. And this is by the central limit theorem. The central limit theorem says as we take more and more samples, we can treat our averages as normally distributed entities. And that's what we're doing essentially. We are assuming we have a large sample size so that we can treat our intercepts and coefficients as normally distributed random variables. So large sample size accomplishes 2 things. A good solution that we can be confident is stable and it's not going to change when the data changes a little bit. Is the solution going to change? And it allows us to perform those hypothesis tests and trust the stars in the R output. In our example, we have 11,254 observations, and it's really hard to say, is this enough? But I can tell you probably 100 observations is not enough, and the more we have, the better. I would say as you add more and more variables, having more sample allows us to not only have the maximum likelihood estimation work properly, but it also helps us ensure that we have the complete information of requirement 1. So I would say observations in the thousands would be okay with us. For this example, I'm comfortable moving forward, but I really want to look at the results and see how well my model predicts before I can say that this is a large enough sample size. If we don't have a large enough sample size, we will see that our prediction accuracy suffers. And finally, just a reminder that we should always check all assumptions and requirements whenever we create a logistic regression model, just as we've done for linear regression. It's important that we're aware of any violations so that we can attempt to fix them and improve our model overall.